8.8c, which is where we are going to be able to model and solve an equation with one variable on both sides of an equal sign arising from a mathematical and real-world problem. So we're tying everything together. Last week we took a real-world situation and we wrote the equation. This week we're going to take it a step further and now continue to solve and answer those questions. Okay, so we're going to be using the same examples. Again, this is just the tiles. So we're going to be using the same examples that we actually already had the equations written for, and we're going to take it to the next step and solve. So it says Andy's rental car charges an initial fee of $20 plus an additional $30 per day to rent a car. Buddy's rental car charges an initial fee of $36 plus an additional $28 per day. For what number of days is the total cost charged by the companies the same? So again, we know we're going to set them this equal because it asks for the same. And what are we looking for? We're looking for the number of days where the total is going to be the same. So the number of days is going to be our variable. So I'm going to write that out. Number of days is going to be represented by X. Okay, now let's go back and talk about how many people we're talking about here. We're talking about our two companies, which is Andy's rental car, which is 1. I'm going to write that over here on the left. Okay, and then we're also talking about Buddy's rental car, which is our second company, which is going to be on the right. Okay, and we know we're going to set these equal to one another. So now we just have to go back and read. It says Andy charges an initial fee of $20. So no matter what, you're going to get charged this $20 plus, okay, plus an additional $30 per day. Now again, we said our variable is the number of days. So we don't know the number of days. We just know it's going to be per days. So our variable is on the 30. Okay, switching over to the right side, let's talk about Buddy. Buddy's rental car charges an initial fee of $36. All right, so no matter what, you're going to get charged $36 plus, okay, plus an additional fee of $28 per day. And so again, our variable is number of days, so our variable falls on the 28. Okay, so 28x. All right, now we need to solve our equation. So I'm going to come down here and rewrite it. So 20 plus 30x equals 36 plus 28x. So I'm going to draw my line down the equal sign to remind me that there are two sides, the left and the right. And since they are equal, if I do something to one side, I also have to do it to the other side to remain balanced. So first things first, I'm going to look at the variables. I have 30x and I have 28x. Okay, again, we want to move the variables to one side and combine them. So here I want to look at, well, which one do I want to move? Do I want to move the 30x to the right, or do I want to move the 28x to the left? In this case, guys, I'm going to move the 28x to the left because if I subtract it from 30, my x is still going to remain positive. So here, if I do that to the right, I also have to do it to the left. Again, this becomes 0 pairs. Okay, that positive 28 and negative 28 cancel each other out, 0 pairs. And then 30 minus 28 is 2x. And then we want to bring down everything else that we did not touch. So that means the 36 on the right plus the 20 on the left. Okay, now I'm going to combine the constants, meaning the numbers that are standing alone, in this case 20 and 36. Now I'm going to move the 20 because, again, same concept. If I subtract 36 from 20, I'm going to get a negative number. So I'm going to subtract 20 on this side and 20 on this side. Again, this positive 20 and negative 20, 0 pairs. So 36 minus 20, I'm going to subtract, and I get 16. And then again, everything else stays the same. But now again, I want my variable to be by itself. Right now it's not. It's 2x instead of just 1x. So since I have this 2x together right here, it's held together by multiplication. So to undo multiplication, I'm going to use division. I'm going to divide by the 2x, meaning I'm putting it into two separate groups. If I divide by 2x, or 2 on this side, I also have to divide by 2 on this side. And 2 over 2 just becomes 1. So now I just have 1x equals, and 16 divided by 2 is 8. Okay, so what this is saying, and again, x is representing the number of days. So it's saying that it's going to take them 8 days for the companies to charge the same amount. And that does sound reasonable, 8 days for the companies to be the same. But we also want to double check. So I'm going to plug it into my calculator, or first I'm going to plug in my solution back into my equation. So wherever I see an x, I'm going to substitute 8. Okay. So here I have my equation. I substituted 8 for x. And now I'm just going to put it into my calculator. All right. I'm going to move this to this side so we can see. So first I'm going to start on the left side. 20 plus 30 times 8 is 260. Equals, now to the right side, 36 plus 28 times 8, and I get 260. So those are equal. So going back to the question, how many days? It says, for what number of days is the total cost charged by the companies the same? Well, the number of days, okay, is 8. Okay, because that's our solution. All right, next example. It says Lorna has $60 and her sister has $120. Sorry about that, guys, the bell. So again, Lorna has $60 and her sister has $120. Lorna saves $7 per week and her sister saves $5 per week. How many weeks will it take for the girls to have the same amount of money? Okay, so we're talking about two people, Lorna and her sister. Okay, so Lorna is going to be on the left and her sister is going to be on the right. We're going to set them equal to one another because it says how many weeks will it take for the girls to have the same amount of money. Okay, also we can look at our variable here. It says for how many weeks. Okay, so that's our variable, the number of weeks. And we're going to represent that with a W this time. Okay, so let's go back and look at Lorna. It says she has $60. So that's how much Lorna is starting with. She has $60. And then it says her sister has $120. So on the right side, her sister is starting with $120. If we keep reading, it says Lorna saves $7. Now, saves. What operation do you think we would choose for saving money? Would it be addition or subtraction? Hopefully, saving money equates to adding money. Okay, so adding will be our operation plus $7 per week. Well, 7, and again, the number of weeks is our variable, so we're going to use W because that's what we're solving for. On her sister's side, it says she saves $5 per week. So again, if she's saving, that means she's adding to what she already has, $5 per week. So again, the W is representing the number of weeks. Okay, so now we want to solve. We want to solve for W to determine how many weeks is it going to take for them to have the same amount. So 60 plus 7W equals 120 plus 5W. Okay, so we're going to draw our line down, our equal sign. And again, we're going to focus on moving the variables to one side first. So I have 7 and 5. I want to subtract the 5, because again, I want my variable to remain positive. So minus 5w on the right, minus 5w on the left. On the right side, we get this 0 pairs. Okay, on the left, we get 7 minus 2, or 7 minus 5 is 2, and the w stays the same. And then everything else in our equation on the left and the right side remains the same. So now that I've got the variables all on one side, now I want to move the constants to one side, meaning the constants in these equations are 60 and 120. I want to subtract this 120, or this 60, so I can keep my constant positive. So minus 60 on this side as well. This becomes 0 pairs. Okay, and 120 minus 60 equals 60. And again, I'm going to bring down the 2w on this side. Now again, I want w to be by itself. Right now it says 2w. I just want w. So in order to do that, again, the 2 and the w are held together by multiplication. So to get the w by itself, I'm going to have to use the inverse operation of multiplication, or the opposite, which is division. So I'm going to have to divide by 2 here to get w by itself. And I'm going to have to do that to both sides. 2 over 2 is just 1. So now I finally have the w, and 60 divided by 2 is 30. Okay, so the number of weeks that the girls are going to have to save is for 30 weeks in order for their totals to be the same. Okay, so our solution is 30 weeks. But again, we want to make sure. So we can do that by plugging in the 30 weeks into our equation to see if their cost would be the same. So I'm going to open the calculator, move it to this side. So now I'm going to substitute, since my solution is 30 down here, I'm going to substitute 30 for the w's. So 60 plus 7 times 30 is equal to 120 plus 5 times 30, because that's where the w is. And then you just plug it into your calculator. 60 plus 7 times 30, I get 270. And then same thing on the right, 120 plus 5 times 30, and I get 270 as well. So yes, their costs are the same at 30 weeks. So 30 weeks is our solution. All right, guys, if you have questions, or if you're still confused or need more help, please join me at the lives at 9:30 and 2, and I hope you have a great day.